Hello, this is Mr. Civil. Please welcome to my YouTube channel. If you have not yet subscribed, please subscribe my channel and don't forget to press the notification button to get all my latest videos. In today's tutorial, I'll teach you on how to determine slope and deflection at a given point of a beam using Macaulay'S method. So the beam that we have over here is a simply supported beam that has only one point load. So let's get started. Using Macaulay'S method, determine the slope and deflection at point C for the loaded beam shown in figure in terms of EI. Take point A as origin. So we have our point A over here, point C over here, and point B over here. At point C we have a load of 50 kilonewtons, and then the distance from A to C is 3 meters, and the distance from C to B is 2 meters. First of all, I shall start by calculating the reaction at A and reaction at B. So I'll take my reaction at A, which is over here, RA, and my reaction at B over here, which is RB, is equals to 50 kilonewtons. When you have another load, you'll have to add the two loads, but for this case we have only one point load, which is 50 kilonewtons, so we shall not add anything. So our reaction at A plus our reaction at B is equals to 50 kilonewtons, and then let's say that the summation of moments is equals to 0. So this reaction at A, it is going like this. So it means that this 50 kilonewtons is going like this. So this is clockwise direction. So when it is clockwise, we use a negative sign, and then when is anti-clockwise, we use a positive sign. For my case, I'll use negative, and then I'll take the load, multiply the distance to get the moment, which is 50 times 3, the distance from A to C, plus the total distance, which is 5 meters from here to here, multiplied by the reaction at B, because I want to find the reaction at B, and then I say that is equals to 0. So when you calculate this, you'll get it as negative 150 plus 5 RB is equals to 0. I want to find the value of RB, so I'll move this 150 to the other side. So I'll have my 5 RB is equals to 150. When I divide both sides by 5, I'll get my RB as 30 kilonewtons. So from this equation, you can get your RA. So my RA plus 30, which we have gotten, this is our RB that we have recently gotten, is equals to 50 kilonewtons. So when I take this 30 to the other side, I'll have my RA as 20 kilonewtons. When I cut a section along this beam, I have already done this a section. Let's say it's section XX, and then I've just come and drawn the diagram over here. So you'll only have reaction at A, which we got it as 20 kilonewtons, and then point C. So point B is not visible because we have cut a section along the beam. So the distance from A to C is 3 meters, and then the distance from A to the point where we have cut the section, we don't know, so I've labeled it as X. So first of all, you just come and write MX is equals to, so this 20 kilonewton load will make the beam to bend in this direction, like this. So when the beam bends in this direction, we take it as positive, and then when the beam bends in this direction, we take it as negative. So this is a positive for the case of sagging and a negative for the case of hogging. So I've taken this 20 kilonewtons times x, which is the distance up to the section, and then because this 20 will bend like this, I've taken it as positive, and then this point load will make the beam to bend like this. So when the beam bends like this, we take it as negative. So I've taken it negative 50, which is the load, into x minus 3. So I get the distance up to the section. But you know that mx is equals to ei d squared y over dx squared. So I've just replaced this with mx. So I've gotten it as ei d squared y over dx squared is equals to 20x minus 50 into x minus 3. So this is our equation 1. When we integrate our equation 1, we'll get it as ei dy over dx is equals to 20x squared all over 2 plus c1 minus 50 into x minus 3 squared all over 2. So this is our second equation. And then when we further integrate the second equation, that is this one, when we integrate this equation, you will get ei y is equals to 20x cubed all over 6 plus c1 x plus c2 minus 50 into x minus 3 cubed all over 6. So this is our equation 3. When we apply the boundary condition, we know that x is our distance and y is the deflection. So when our x is equals to 0, x is equals to 0 at this point, so our y will also be equal to 0, and hence our c2 will be equal to 0. When you replace the values of x and y over here in this equation, you'll get that c2 will be equal to 0. And then when our x is equals to 5, our deflection will be equal to 0. So you can see that our 5, the distance, when it is here, the deflection will be 0. And when I replace the values of x is equals to 5 and y is equals to 0 and c2 is equals to 0 in equation 3, in this equation, I'll get it as 0 is equals to 20 into 5 cubed all over 6 plus 5c1 minus 50 into 5 minus 3 cubed all over 6. And then when you calculate this, you'll get it as 416.67 plus 5c1 minus 66.67. And then I want to find the value of c1. So this will cross the other side, also this one will cross. So when they cross, I have my 5c is equals to minus 416.67 plus 66.67. And then when I divide all over by 5, I get my c1 as negative 70. So when I replace the value of c1 is equals to negative 70 in equation 3, I'll get my equation as EI dy over x is equals to, so the first case I've replaced it in the second equation, and then the second case I'll replace in the third equation. So when I replace in the second equation, I'll get it as EI dy over dx is equals to 20 x squared all over 2 minus 70 minus 15 to x minus 3 squared all over 2. So they told that we leave our answer in EI, in the form of EI. So I've divided all over by EI, so I'll get as dy over dx is equals to 10x squared minus 70 minus 25 into x minus 3 squared all over EI. So this equation is our slope equation. So let's go and find our deflection equation. So I'll replace my value, which is the value of C1, which is negative 70 in equation 3. So you can see that EI y is equals to 20x cubed all over 6 plus into brackets minus 70x. So this will turn here to be negative minus 50 into x minus 3 cubed all over 6. So when I divide all over by EI, I'll get my deflection, which is y is equals to 10 all over 3x cubed minus 70x minus 25 over 3 into x minus 3 cubed all over EI. So this is our deflection equation. Because they have told us we leave our answer in form of EI, we shall just stop there. But if we were given the values of E and I, we could go further and find the slope at a given point, or the deflection at a given point. So that's all about. Thank you for watching my video. If you have not yet subscribed, please subscribe, and don't forget to press the notification button to get all my latest videos. Thank you very much.